Alrighty, guys, what's up? We're doing these rational function graphs, aka graphing rational functions. Quiz 6 review. Let's hop right into it. So if you are in my class, just FYI, we have not yet talked about domain of these ones quite yet, nor have we talked about these words, the limit behavior of all vertical asymptotes. But I will be describing those in this video because I'll be teaching them in class in the near future here. However, everything else we have covered, so let's hop into it. So step one of the 7-step process that I gave in class. By the way, if you are somebody watching this video who is not in my class and you would like a copy of the notes, they will be in the description below. You can just click the link and a picture will pop up. All right, so step one in that 7-step process is factoring. So you need to factor that top and bottom. You're figuring out the numbers that multiply to +4 and add to +5. In this case, we're going to get x plus 1 multiplied by x plus 4. Please note, if you're struggling with that, you also have the option of the quadratic formula or simply doing the graph and figuring out the zeros from there too. The other option here at the bottom, you got to figure out what multiplies into -8 and adds to +2. In this case, we're going to end up with +4 and -2. So there's our step one of our 7-step process. So I'm going to go ahead and start labeling these with our step 1 right there. And now we go on to step number 2. Step number 2, you have to remember one of our big rules is looking for cancellations. So step 2 is you're looking for cancellation. For this particular problem, you should be noticing that, hey, the +4 and the +4 cancel out on the top and bottom. So because the +4 and the negative, sorry, what am I saying, negative? The +4 here cancels out on top and bottom. We can rewrite this function as x plus 1 over x minus 2 with a whole at x equals -4. Specifically, it is the 0 of the asymptote. So you're taking that +4, it's -4 plus 4 gives you 0. That is where that whole is going to occur. And then you plug that -4 into both of the x's. So you're going to go ahead and you're going to say that f of -4, what it would have been if you could have, would be -4 plus 1 divided by -4 minus 2, which is -3 over -6, or simply a positive a half. So you have a whole at -4 comma 1/2. There we go with step number 2. For step number 3. Step number 3 says you're going to see setting that numerator equal to 0. So for us, that should be nice and quick. Simply saying that we have a 0 at x equal to -1. Again, these are our zeros. Same exact thing as an x-intercept, by the way. So 0 or an x-intercept at x equals 1, and that guy has a multiplicity of 1. So the multiplicity is how often this x plus 1 shows up. It only shows up one time. There are no exponents here. There will be future questions that do have multiplicity, but not this one, is multiplicity of 1. So step number 4 here of that multi-step process, we have to figure out the vertical asymptotes. So the vertical asymptotes for this one, I just like using V-A for my vertical asymptotes. And my vertical asymptote is going to be at x is equal to +2. It's where that denominator equals 0. And that is also going to have a multiplicity of 1. Step number 5. So step number 5, I'm going to hop down over here, kind of, there we go. Step number 5, we have to figure out the end behavior. So our end behavior, for this one, what we're going to be doing is comparing the degree of the numerator versus the degree of the denominator. In this question, it's nice and easy because there's only a single value on the top and bottom. We simply have this x plus 1 over x minus 2 that we're working with. And because we're just looking at this x plus 1 over x minus 2, the degree of the numerator is 1, and the degree of the denominator is also 1. It is simply the largest exponent in the question, and again is just a 1 over a 1. Anytime you have a 1 over a 1, you need to immediately look at the, instead, leading coefficient of the top and the bottom. So these are the degrees. I'm going to switch to color here just to talk about. These are degrees because the degrees are the same, because they are equal, so because they are equal, we compare the leading coefficients now. However, the leading coefficients of the top function is simply a positive 1, that the x plus the x right there has a leading coefficient of 1, and the leading coefficient of the denominator is also 1. So a lot of 1s in this problem will not be that way in every single question, definitely not even that way in the next problem. But because you have that leading coefficient as 1 and 1, the end behavior here is going to be that 1 over 1, which is simply 1. Woof! All right, so we are almost done. We now need to figure out a starting point. A starting point can be any value that you feel like. So the starting point that we're going to be using for this one, I always recommend doing the intercepts because that's even part of the definition up here that they wanted here anyways. So for this one, we're simply going to plug in 0 for our starting points. And that starting point is going to be, like I said, we're going to make it x equal to 0. This is an optional value, arbitrary. You can pick any value that you want whatsoever. So we have x is equal to 0, and you're going to go ahead and plug that in. You get f of 0, and you're plugging it into this one up here, this x plus 1 over x minus 2. So 0 plus 1 over 0 minus 2, and that gives you negative a half. So you have this starting point of 0 comma negative a half. We have finally written down all the information that we need to actually start graphing the problem. So we have this original value of 0 comma negative a half. We can mark that up on our graph. We have this y is equal to 1, and remember that the horizontal asymptotes only occur at the ends of the graph. So y is equal to 1 here, but we only actually start putting it towards the end of the graph. Technically, it must come after the last 0 or asymptote that you've written, but it doesn't need to come immediately after that last 0 asymptote. It could come anywhere afterwards, as long as it happens towards the end. Remember that horizontal asymptotes are allowed to be crossed. It's the vertical asymptotes that cannot be crossed, and that's the next thing we're going to be drawing up, the vertical asymptote at x equals 2. Because we wrote a vertical asymptote at x equals 2, we now go ahead and put that dotted line all the way up. There we go. X equals 2 has been written in. We finally have this 0, or this intercept at x is equal to negative 1. That's going to be right here. The very last thing we have to write down is our hole. We have a hole at negative 4 comma a half. So you have at negative 4 comma a half, we have this empty circle that we have to write in there, right there at negative a half. We finally finished writing down all the information that we've actually done. The last thing to do is to graph the problem itself. So to make the graph show up, here's what's going to happen. We're going to go ahead and start at this starting point that we did. The whole reason we wrote the starting point was to start there. We're going to start right there, and you have a choice. You have a choice of either going up or going down, and you have to use logic to figure out which one it must be. The reason why you cannot go up, you again cannot go up, is if you went up, you would cross the x-axis. However, we already wrote down the only time there is an x-intercept, the only time that occurs was at negative 1. So that's the only place you're allowed to cross the x-axis, and therefore the graph must go down. But you cannot cross the vertical asymptote, so the graph goes towards that vertical asymptote. Continuing on, moving right. Looking at our notes, we know that because the multiplicity of the asymptote is exactly 1, the graph does not point down again. It instead points up towards the other asymptote. So it's going towards that asymptote up here, and the only thing left to do is to go towards the last asymptote. It is actually possible that the graph goes below the asymptote and then back towards it. The only way to truly figure that out is if you plugged in 3 and 4 and 5 and 6 and you tried to figure out, does it ever actually go back below? I am not going to stress about that. I just want a rough sketch, making sure that you know all the ideas about asymptotes and end behavior. Continuing from the starting point, though, you have to go left. In this case, it's kind of nice and easy where you're just going to be playing connect the dots because you already have this dot here and you have this dot there, and it's going to go towards the asymptote. So this one, there's really not much thinking about it. So we're just going to go ahead can graph it just like so, and we're done. We have our nice, beautiful rational function graph. Let's move on to the next one. So problem number 2. Problem number 2, we again have to factor to start. So this one has a nice, easy factoring. There's really not much to this one. We simply have 2 multiplied by x minus 2 divided by x plus 1. So that was a very simple factoring. Nice, easy step number 1. For step number 2, also a nice and easy step on this one because there are no holes on this question. And there's no holes because there's no canceling. The x minus 2 doesn't cancel with the x plus 1, so there's no holes. We're done. We don't have to worry about it at all. We're moving on to the next step. And actually, that should have been in blue, but whatever. All right, step number 3. Step number 3 is finding the zeros. You're setting that numerator equal to 0. In this case, we simply have x equal to 2 with a multiplicity of 1. After that, we're on to step number 4. Step number 4 is finding those vertical asymptotes. The vertical asymptote is when the denominator equals 0 after you've canceled out the holes. So you're going to have x is equal to -1. I also realized I didn't do the limit behavior stuff for that last problem, so I'll have to go back to that later. I'm not too worried about it for this first quiz, though. So maybe later, and maybe if someone harasses me about it. All right, so x is equal to -1, and the multiplicity is 1 yet again. After you have done that, we have a step number 5 of thinking about the end behavior. The end behavior for this problem is almost exactly the same as the previous one, except we have a slightly different leading coefficient. So for that end behavior, you have, yet again, the n is equal to 1 and the d is equal to 1, so you have to compare the leading coefficients. The leading coefficient of the top this time, though, the leading coefficient of the numerator, that is equal to 2 this time because there's that 2 chilling out in front, and the leading coefficient of the denominator is equal to 1, so our value is y is 2 over 1, or simply just 2 for our end behavior for y. We still need to figure out our starting coordinate, which we usually choose as the y-intercept. So that's going to be our step number 6, our starting point. So our starting point here, I forgot to write the word zeros up here. And then here we have a starting point, just SP. So starting point, we're again making x equal to 0. When you plug in 0 here, it's going to be pretty quick. You plug in 0, you're going to get -4 over 1. You get -4. When you plug in 0, make all those x's equal to 0. So our starting point is that 0, -4. We have end behavior of y is equal to 2. Again, you're only putting that towards the end of the graph. If you want to know where towards the end of the graph you put it, there's no exact science to this. Once you get to calculus, there'll be a more exact science for it, but we're not worrying about that right now. If you want to know the exact science once you get to calculus, in case you're like a calculus teacher watching this or something, it's after the last critical point is the place where the asymptotes begins after the final critical point. Anyways, continuing on, we have the y equals 0 and -1 for our asymptote. So we have x is equal to -1 for this vertical asymptote. We got that from this information. We have a 0 at 2, so that means we have the 0 here. And that is all the information that we were given. So we begin at our starting point right here, and I like moving to the right first. So here, it's a nice, simple connect the dots going towards the asymptote. There's really not too much to think about here on this side. On the left-hand side, though, you do have to use that logic. Are you going up or down? Once you've drawn this picture, it is more clear that you're going down here. But as a reminder for the logic, you couldn't possibly go back up because you'd cross the x-axis, which we wrote down. The only time we cross the x-axis here is 2. Continued on with our asymptote here, this vertical asymptote at x equals -1, had a multiplicity of 1. From the notes, we know that it does not go down together. It instead goes back up. And because it goes back up, we can now finish and draw our graph going towards the asymptote. Yet again, I will mention it is actually possible that this graph goes down to -4 and then back up here. I'm not worried about that for this quiz. And if you really wanted to, you could plug in -4 to see what it is. I wonder what would happen actually if I plugged in -4. If I plugged in -4 here, it would be -12. It would be +4. Yeah, it definitely does not go below in this one. Yeah, that's pretty much it for this question. Let's move on to the next one. Ooh, I like this one. This is an interesting one. So yet again, our very first step is to factor. So we're factoring, nothing to factor on the top, obviously. On the bottom, the numbers that multiply to -3 and add to +2 are going to be +3 and -1. So there's our step number 1 finished. Our step number 2, hopefully this one's obvious. There are no holes. Yeah, that one should be very clear. There's no canceling. You can't cancel out with just a 1 chilling on the top. However, we haven't had a question like this, and if you're watching this like really early on, you might also notice that we've never done a question just like this in class either, where we have no zeros. So actually, I need to make sure I do one of those in class tomorrow. So we have no zeros. Step number 4. This question's funny. We have no holes, no zeros, no work to do. All right, and now we have vertical asymptote. So our vertical asymptotes on this question, we have 2 of them. So x equal to -3, where the multiplicity is 1. We have x is equal to 1, with it also a multiplicity of 1. And now that you have that, we can go on to step number 5 for that end behavior. So the end behavior here, the end behavior, the numerator's degree is 0 because there are no x's, so it's a 0th degree polynomial, we say. And for the denominator, the degree is 2. Because the numerator is smaller than denominator, we have an automatic rule. The automatic rule is that y is equal to 0 is our asymptotes, or our horizontal asymptote, our right-hand end behavior. Step number 6 is figuring out a starting point. For this one, I again recommend plugging in 0. Plugging in 0 might not be perfect for this because you didn't get a fraction, but it's still going to work out for us. If you do plug in 0 for this one, a starting point, plugging in 0. Plugging in 0 here, you get 1 over something for sure. Plugging in 0, you get 3 times -1, which is -3. So you get -1/3 for a starting point, and we can start doing our graph. So we have a starting point at 0, -1/3, so about right there. Our end behavior is y equals 0, so we're going towards this asymptote here of y equals 0, which, by the way, if you forgot, that's the x-axis. And continuing on from here, x equal to -3 for 1, 2, 3. And then we also have x is equal to +1. So -3 and +1. And now we just have to start doing it. So this one's weird because it never crosses the x-axis. If there's no zeros, it never ever crosses the x-axis. You're never going to cross that line. So from here, the only option is to kind of go back towards this asymptote. And for here, it's the same thing. Now, it could be that 0 is actually the lowest value on the problem, or it could be that the lowest value is somewhere over here. And yet again, you will only figure out exactly where that little value is up there, like how high up it goes, once you get to calculus. So for now, I would just kind of estimate it. You can make that the highest point there. You can make this the highest point. Doesn't really matter. And on this one, I would not be surprised if it was a decimal of some kind. Doing math in my head a little bit. Actually, it actually does occur at 0 on this one, I'm pretty sure. So anyways, there's that. At x equals 1, though, it's going to hop back up because both of these multiplicities have multiplicity of 1. So neither of these point the same direction. So we know it actually goes up on both of these. And then it has to go towards the asymptote. And on this one, we actually know for sure that it does not cross that asymptote because it can't cross the x-axis. And it's going to happen on both sides. So it looked a little bit intimidating, but that one's actually done. Moving on to the next question. Here we go. Let's start. So we have to factor. This one does have a little bit of extra work in terms of the factoring. So let's hop into it. For that step 1, you factor out an x first, then you get x squared minus 1. And on the bottom, you should factor out a -4x. And that will give you x, what is that going to be? X plus 3. But you're not quite done with that x squared minus 1 because it factors some more. So it factors some more and it becomes x times x plus 1 times x minus 1. And this one is already done being factored. So there's our step 1, a little bit of extra work there and the factoring there. After you've done that step 1, we move on to step 2 for the canceling. For step 2 on this one, there is a hole. Specifically, the x's cancel here. So the x's cancel, and you end up with, it becomes x plus 1 times x minus 1 over -4 times x plus 3. And again, those x's cancel. And because those x's cancel, you have a hole at x equals 0, which by the way means that you can't have 0 as your starting point because it's not actually a value for this problem. However, you still are going to plug in 0 to figure out what you get. Looks like you get a -1 on the top and a -12 on the bottoms for a positive 1/12 for a hole at 0, a 12th. For step number 3, you're setting that numerator equal to 0. So we have x is equal to -1 with a multiplicity of 1. We have x is equal to +1 with a multiplicity of 1. These are our zeros again. And step number 4, we have our vertical asymptote. So we have a vertical asymptote at x is equal to -3. And with that vertical asymptote at x equal to -3, we have a multiplicity of 1. Step number 5. Step number 5 is going to be a big one for this question, so I'm going to get off a lot of room here. And the reason why is pretty simple. For this one, when you first check the numerator versus denominator, and again, you're checking it once you've done some cancellation. Here, the numerator's degree is equal to 2. The denominator's degree is equal to 1. Because of that, we know that we have the numerator bigger than denominator, which means there is no horizontal asymptotes. And you have to do some extra work for the end behavior. So for the end behavior, this is the question that you kind of dread seeing when you're doing one of these because you know you're going to have this extra work to do. So we need to look and figure out what x plus 1 times x minus 1 divided by -4 times x plus 3. We need to figure what that looks like at the ends. In order to do this, we need to do long division or synthetic division. In order to do either of those things, we need to re-multiply out the top. So it's x squared minus 1 divided by, and now we're going to re-multiply out the bottom, -4x minus 12. So we went back to that. And we need to go ahead and I think it's going to be easiest, actually, because that -4 is a constant. It will be easier just to refactor it all the way out to make it -1/4 multiplied by x squared minus 1 divided by x plus 3. Yeah, that'll make your life easier. And now we need to do synthetic or long division. I'm pretty sure most of my students are going to prefer doing synthetic division. If you prefer long division, you go for it. Or if your teacher requires it, obviously go for it. But we're going to do synthetic division. So synthetic division here is going to be -3, a 1, a 0, a -1. The 1 comes down. -3 there, -3, +9, and you get 8, which means that this is our remainder, our constant, our x. So we have x minus 3 plus 8 over x plus 3. And our end behavior on this graph is whatever is not the remainder. So x minus 3 is our end behavior. If you're going way back in time and forgot what x minus 3 looks like, that is a basic straight line. I'm talking about the line y equals x minus 3 is our end behavior. So just like before, we had like x equals 5 is the end behavior. Y equals x minus 3 is the end behavior. So minus x minus 3, look at that. It's our slope-intercept form. Y equals mx plus b. We're going back old school in this one. Our end behavior only occurs at the end of the graph. But we kind of need to graph the whole thing because of being able to figure it out. But towards the end of the graph will go towards this y equals positive x plus 3. There's our end behavior line. Yikes. Like I said, lots of extra work to do. And, oh no, I forgot about the -1/4. Now I have to, like, redo this graph. Dude, I want to cry. All right, so we're going to ignore this dotted blue line because it's nonsense because we forgot that -1/4. We have y is equal to -1/4x plus 3/4. So even worse than that. Now we have yeah, what an annoying problem now. All right, so we have 3/4 as a starting point, like right there, and it has a -1/4 slope, so it's like over 4 down 1. So it's like this. as our end behavior. And oh man, I apologize. Now we have a confusing looking graph. We have this useless dotted line because I decided to use pen. Cut from the team, Mr. Richards. This is why you don't do math in pen. Anyways, here we go. There's our end behavior because we have to multiply by that negative 1/4 in front. Finalizing this one, we have a starting point that we need to choose. The starting point cannot be 0 because we already had a 0 that we used over here. So we have to choose a different starting point. So I'm going to just go ahead and choose another arbitrary starting point. How about 2? So I'll start off at 2. And again, there's no reason for that plugging in 2. I'm just kind of randomly choosing a number. But when I do plug in 2, I'll plug it into this one because I think it'll be, well, maybe this one will be easiest. 2 plus 1 is 3. 2 minus 1 is 1. So you get 3 divided by negative 20. So you have 2 comma negative 3/20, which is like right there. Okay. You also know, so that's our starting point. We have a bunch of other stuff to write down. So we have this this whole at x equals 0 comma a 12. So you have a 0 to write right there. We have a 0 at 1. We have a 0 at negative 1. What else? We have a vertical asymptote at x equals negative 3. Is that all of my information that I've written down? We got the whole, the zeros, the vertical asymptotes, the end behavior. Whew! All right. So again, we have all these values. The end behavior, it's going towards it. So we probably just want to go towards that end behavior over here from our starting point. On the left-hand side, we can kind of just play connect the dots. So that's kind of nice. So we just play connect the dots. We go towards that asymptote. And again, popping up, going towards the end behavior. And then this dotted line again is still useless. Hopefully the next one makes more sense because I feel like I did not do the best job on that problem number 4. Let's move on to problem number 5. So problem number 5, yet again, we're going to have exactly the same situation with that oblique asymptote, the sideways asymptote. Let's make it happen. Doing this entire thing, we got to factor that top and bottom first. So factoring the top part of this is going to be x plus 2 times x minus 1. It's still a 4x on the bottom. There's our step number 1. Our step number 2, there are no holes here because there's no canceling out. Step number 3 are zeros. There are zeros on this one. There are 2 zeros. The zeros are x is equal to negative 2 and x is equal to positive 1. Both these have multiplicity 1. I didn't do any multiplicities bigger than 1 on this whole thing. That's kind of not the best problem, Mr. Richards. You should have picked some better problems. Oh well, life goes on. So we have there's our zeros with those multiplicities. We also have to do our vertical asymptote. This one's kind of interesting. We have a vertical asymptote of x is equal to 0, also with multiplicity of 1 because of that 0 here at the bottom. And oh my gosh, I wasn't even able to see that negative 2 and that positive 1 while I was whining about not having any multiplicities on this whole question. Our end behavior for this problem, almost exactly the same as the last one to begin. The end behavior has a numerator degree of 2, a denominator degree of 1, the highest exponent over highest exponent, which means that we have no horizontal asymptote. Because there's no horizontal asymptote, you instead have to do some long division. So now we're going to do, or synthetic division. So we have to do some synthetic division here. The synthetic division is somewhat interesting because you don't actually have to do full synthetic division because it's just a 4x. This is a great question to do. This is actually just a version of distributive property. Remembering all the way back to our Algebra 1 years, if you have a plus b over c, that's the same thing as a over c plus b over c. And therefore, this one's going to give you, when you do x squared minus or plus x minus 2 over 4x, the original question, that's going to be x squared over 4x plus x over 4x minus 2 over 4x. You're just applying this rule right here, which simplifies to x squared. Oh, it doesn't. Yikes, Mr. Richards. It just simplifies into x over 4 plus 1 over 4 minus 1 over 2x. The end behavior is everything except for the remainder. This part right here is the remainder. So this is our end behavior, which is really the equation y is equal to 1 over 4x plus 1 over 4. So we start off at this 1 over 4 point, and we are going up in a positive, up 1 to the right 4, up 1 to the right 4. So we're starting off here, up 1 to the right 4, and then up 1 to the right 4, maybe down 1 and to the left 4. So your end behavior is going to be this line here. We still need a starting point. A starting point for this one, I'm going to have to move over here for step 6. A starting point on this graph can be anything that is not a value that we've written down, so you cannot use -2 or 1 or 0, but it looks like we can use, we are going to be able to use maybe -1. -1 could be a good choice. So if we're going to plug in -1 into this problem, you're going to get +1 there, -2 there. I'm just plugging in -1. So +1 there, -2 there, -4 there. So that's going to give you +1/2. Just in case you needed help seeing that on a calculator, you can just do alpha y equals enter for that fraction, and you're plugging in -1 into this. So -1 plus 2. And I chose -1 arbitrarily, which means that you could have chosen any other number. So -1 is not a requirement, but like I said, you do get a half either way for that one. And that's going to be where you're starting off the graph, which is just barely above this, because this is starting at a 4th. So this is just barely above this asymptote, barely above it. We also have some other zeros to write down. We have a 0 at -2. We have a 0, -1, comma. Why did I write 0? I literally said -1/2. My. -1, comma, 1/2 would be more like right here, barely above this line. So there's the starting point. In fact, x equals 0 is a vertical asymptote, so that's going to be a dotted line up and down this entire axis. Yikes. All right, so you have that dotted line of that entire axis. We also have zeros at -2 and at 1. And this was our starting point, was at -1. So going right towards the asymptote there, towards this asymptote there. And then from that, we have the other side. It's got to hop down. Got to go through that 0. And there we go. We finished up our graph. A little bit crazy for the entire thing. Hopefully it all comes together for this last one, because this last one should be nice and easy. So we're going to factor out first that we have a -1 that we can factor out, x plus 3 divided by x plus 1. There is our step number 1. Step number 2, yet again, no holes here. Step number 3 for this one, we have x is equal to -3 with a multiplicity of 1, and that's our zeros. Step number 4 here. For step number 4, we have our vertical asymptotes. Our vertical asymptotes are going to be at x is equal to -1, also multiplicity 1. Like I was saying, I did all multiplicities of 1 only on these guys. But so it goes. The end behavior here, for the end behavior, we have the numerator degree is 1, the denominator degree is 1, so we have to compare the coefficients. For the coefficients, our leading coefficient of the numerator is -1, the leading coefficient of the denominator is +1, so your end behavior is y is equal to -1 over 1, or just -1. And for our starting point, definitely just plug in 0. And if you do plug in 0 for a starting points, you get 0, comma, looks like -3 when you plug in 0. So we have 0, comma, -3 to begin. We have our end behavior of y is equal to -1, which we graph towards the end of the graph. We have a vertical asymptote at x is equal to -1. We have a 0 at x is equal to -3. And we have no holes, so that's it. So we have our starting point that we did at 0, -3. Going off here, there's nowhere to cross. There's nothing to do. Just go towards the asymptote, and that's all you have to worry about. Going left, we must go towards this guy here, hop up to the top, cross through, and there you go. There's the entire thing. Hopefully this video was useful. Have a great rest of your day. Peace out.